Hi, everybody. I'm David Coleman. I'm Director of Product Marketing here at Extreme Networks. You might also know me as an author of a lot of Wi-Fi books. Today, we're here to talk about the modern data ecosystem, and I'm with my good buddy, Marcus Burton. Marcus, you want to introduce yourself?
Yeah, thanks, man. I am Marcus Burton. I'm a part of the office of the CTO here at Extreme Networks. I'm an old wireless guy, just like David, but I've been working on some cool data science and cloud projects recently. So glad to be here.
Okay, so what we're here to talk about is what we call the data pipeline, and talking about how data goes up this process to eventually finding its way up into the cloud, and how you can use that as a network administrator. And we all know that data holds value. Data is power. If you can use data in the proper ways, it can help you increase revenue for your business, as well as reduce costs, improve your operations, and maybe even mitigate some risk and enhance your overall experience for your business. Um, you know, Data helps provide insights into your network, and that in itself is the true value, is the insights you get into your network. So what we're going to be talking about here is the 7 stages of the data pipeline, starting from the first stage of when you collect your data, all the way to the last stage where we can actually provide some visibility.
Yeah, it's like the 7 stages of grief or something. At the end, you're made whole. No, yeah. So we're going to start here at the first stage, but like David said, we believe data translates into value. So we're going to talk about this pipeline as a way to sort of we'll talk about the stage, and then we'll show you sort of an example of how that stage translates into value in the end case. So at this first stage collection, this is where data always starts somewhere, and so in a network model where we're looking at data and telemetry, we're talking about collecting data from different places, potentially software or agents that are sitting on the client device, inline infrastructure like access points, switches, routers, and then you've got different types of overlays like sensors on the wireless network, or types of collectors that are maybe seeing traffic on the network, like from a span or mirror port, and performing DPI on that data. And what really matters at this data collection stage is whether your data is granular, so whether you're getting enough of the right data at an accurate with accurate measurement and in the right sampling intervals, whether or not it's expensive to collect and how you pass that cost on to customers ultimately, and then whether or not it has any impact on client service. So obviously for devices that are serving clients, we don't want them to be gathering telemetry about the clients in a way that jeopardizes the experience of those clients.
When you talk about data collection, I got to tell you, probably the question I get asked all the time is, well, what kind of data are you collecting? Is it our user traffic? And the
Yeah.
answer to that is actually no. What we're collecting is what is known as metadata. It's about what is going on with your network and the clients that are connecting your network. And probably a simpler way of putting it is management traffic. So please know that user traffic itself does not find its way up to the cloud. So in this little demo here, I'm going to show you how data can actually be visualized, and kind of reemphasize that it's being collected from multiple points. So this is called Client 360 View and Extreme Cloud IQ. When you talk about Wi-Fi or wired networking, user experience is king, and we try to visualize that user experience. So we're giving you in this view both a real-time and a historical view of client traffic in this client's experience. And so you can see a kind of a low level or high level topology view right here of this client. Based on the data that is collected from an AP at 1 minute intervals, you can see the average RSSI and SNR of this client. So think of it this way: the client is sending information to the access point, but then the access point is acting as a data collector that is sending that data then up to the up to the cloud. As I mentioned, it's being collected at 1 minute intervals, but what you should know is sometimes it's almost instantaneous because client session states change. So this is a mobility trail, or another way of putting it is a roaming trail. Mobility and roaming is key to the Wi-Fi. And so whenever there's a change in a client session state, you should know that that information pretty much goes straight up to the cloud from the AP, and you don't have to wait on a 1 minute interval. The other thing I want to point out as well is that data is being pulled in from not just the AP and the client, but it's also being pulled in from other points, including the wired network. So you can see information about this client's VLAN, its user authentication name, and the user profile and authentication type that was used. So information that security information and wired networking information that's being pulled in from switches and radio servers and other parts of your network are also feeding this view.
Yeah, I love the way that demo shows perspective of different types of collection and input. And then the next stage after collection is basically that collector has to package it up and get it to the cloud. So we call this serialization, but it's also got to be tunneled. So you got to package it up and then you got to tunnel it into the cloud. So the whole point of this stage is basically getting it there, but you got to get it there at scale. So the cloud's got to be able to handle these collection sources from thousands or hundreds of thousands of devices at a time. So it's got to handle it at scale, ingest it at scale. It's also got to be secure, and it can't use too much bandwidth, or else now you're consuming all of your WAN just for telemetry again. And it's also got to handle data variety this stage, from access points, switches, other types of devices that are all sending data into the cloud. So a lot of challenges at this stage, but it's also a critical stage to make sure the data gets there in the right way.
And just to reiterate what Marcus is saying about data in transit is, number one, it's got to be secure. So you can use multiple protocols to send the data to the cloud, but it has to be encrypted. And we'll talk more about that. Another thing that we always get asked about is the amount of bandwidth that is used from data in transit. And WAN uplinks are typically can be bottlenecks. But once again, this is metadata that's being sent up to the cloud. It's not user traffic. So the impact on your WAN uplink bandwidth is like nominal. So this is a CLI demo of data in transit. And what you're looking at is the communications between an extreme access point and our cloud architecture. And we use a protocol called CAPWAP. It is a secure protocol that is encrypted. And there is a discovery process that must first occur between the access point and the cloud architecture. So you can see those discovery packets being sent by the AP. The AP's management interface actually sends those discovery packets, and they're being sent to what is called the redirector. Another name for the redirector is the global data center. The role of the global data center is to then redirect this networking device to a regional data center that is tied to the account of this specific device. And you can see that has happened. It's communicating with a CAPWAP master server in a regional data center. There is a few more steps in this data in transit discovery process, including a DNS query. And you can see right here that the DNS has been resolved, and we are indeed, this device is indeed in the Japan regional data center. Finally, while in that data center, the master server will reassign the device to a final CAPWAP server that is used for all the data transit communications from that point on, and that's what just happened right there. And finally, there has to be encryption. So you'd see a DTLS encryption handshake right here to make sure that the data in transit is secure in transit. And so we have encryption, and what that provides is an eventual CAPWAP tunnel that is up and running, and now data can be securely transmitted from it, in this case, a networking device like an AP, up into the cloud.
So despite the fact that a CLI demo like that, David, is not the sexiest way to show sort of data in motion, but it's super important, and it sort of reinforces the point that we're trying to make about transporting data in a secure way. You also highlight some cool things about our cloud architecture, the GDC, RDC, design in a way that you can connect to the global data center, but then your ultimate connection and all your data is being stored in a regional data center, which is distributed throughout the world, which benefits both latency. So you're connecting to a data center that's near you, but also data storage requirements, which might have sort of privacy implications for certain countries or geographical regions. So, you see this geo map here just as kind of an illustration of that architecture. So, once we've got all that data stored, um, or sorry, we've got it into the cloud, and so it's been decapsulated and put into a message bus so that the cloud can ingest it. The next stage is something that we call data processing, or this is sort of ETL and compute, which is basically the process of actually ingesting or receiving that data, transforming it and processing it so that it has good data hygiene, we'll call it. So, there's a lot of different steps that can happen there. And then ultimately running it through different types of machine learning or data processing where we're trying to mine out and extract out value from the data. What really matters at this
Well,
stage is just making sure that your data has, good hygiene. In other words, it's clean, usable, bug-free, it's complete, it's sampled well, that you can actually process the data at scale, so you're not dropping data, and that you're handling, high volumes of data here, and then just ultimately the quality of sort of that processing, whether you can actually solve problems with that data. So instead of doing a demo on this stage, what I want to do to illustrate this machine learning data processing layer is just kind of give you a glimpse into one of the exercises that we did as we looked at client health. So you think about this as a network admin and you're thinking about client experience on a network, there's kind of a few sort of common things that we care about. Like, did the client connect successfully? How long did it take them, or how difficult was it to connect? And then once they were connected, what was their experience? So when you kind of break down those three pieces of the puzzle, the first thing that we did was we went and looked at the data that we had, both globally, regionally, and then also built layers so that you can process this on a per customer local basis. But we looked across different authentication or connection types and basically identify how long does it take on average for a client connection in a specific for a specific authentication type. And what this allowed us to do is basically baseline what's normal, and then we can take this as just one input to the algorithm that basically determines client health, so that we can start to think about client health holistically across all those dimensions, and then apply or layer things like anomaly detection on top of that logic or that information that we've already learned.
so Marcus, as a longtime Wi-Fi guy, I have to ask you here, could you tell me about the times that you saw here in the data regarding the authentication times? Which one is the shortest?
Well, so open is always the shortest, unless there's a captive web portal. Then it's sort of all over the place. It's a rodeo when there's a web portal involved. After that, it's web and PSK are kind of the next quickest, and then 802.1x is always the longest.
And I see WPA3 SAE, but it doesn't look like you have a lot of data on that yet.
Right. Yeah, that's one of the things we learned as we support it, but there's not a whole lot of uptake yet. I think as client devices start supporting it more, we'll see more uptake on that one. So, we got all this good data, we've processed it, and then we want to put it in storage and start to make it more available for usage. And so, one of the things that you'll see in modern data architectures is to solve the problem of data variety. So there's lots of different types of data: structured data, semi-structured data, all that telemetry we talked about. You need different types of databases. So you'll see that in our architecture as we support an in-memory cache, which is really high performance, but it also is more expensive to use that storage. You see structured data for things like configuration and inventory data, admin accounts, high performance warehouse for your reporting and your sort of data analytics. And then you have data backups. So all these different ways to store data that have different performance requirements. But then there's also issues here like, where is your data stored? So we talked about that as part of the RDC conversation. Is your data stored securely? How long do you keep it? And then just what are the costs of different types of storage, and how do you translate that to the customer? Does the customer pay for that? Or, how do you sort of optimize for cost with storage?
It's also important to point out that you might, in the cloud, you can access the data sometimes faster than others. For example, the cache data right there, a good example might be a PPSK lookup, something that needs to be accessed right away, whereas other data might take a little bit longer to access, like the backup server data.
Right.
Should also understand too that everything in the cloud, it needs to be encrypted. So we use AES 256-bit encryption, and depending on the circumstances too, we might need to dynamically or statically grow our data storage. Even at the RDC level. And like one example is recently, we, due to data needs, we had to stand up a new regional data center in Europe, and we were able to do that in under 30 minutes time. So when you're talking about data storage, one of the advantages is it can give you a historical timeline about what's going on with your network. And what we're looking at here is one particular device. We're looking at an Exos switch right here. And you can see that I have a full week's worth of data regarding about the health and the amount of traffic that is flowing through this switch, and also its PoE capabilities. But guess what? I can change that timeline. And in a second here, you'll see that update, and it'll update for 30 days worth of data. So I can give you 30 days worth of visibility, which is pretty standard in the the cloud management and networking industry. However, at no extra cost to you, we actually, in all our customers' accounts, provide a 90 days worth of visibility. So right off the bat, you have this timeline view that you can zoom in on and for 90 days, 30 days, or a very specific time period, and to evaluate and see what's going on with your network. Now we do this at a lot of different levels. We can do it at the switch level, we can do it on other device levels like branch routers and access points, and also at the user level and the client level. Having that 90-day data horizon, that provides value, and that of course takes storage in the cloud. But wait, there's more. There's more than 90 days. We actually have unlimited data. So any new Extreme Cloud IQ customer, what they can actually do when they set up their cloud account, they can actually choose. Do they want 90 days worth of data, or do they want unlimited data, which is kind of unheard of in this industry? So we actually provide storage for unlimited data from the point that you create your account, if that's the kind of timeline and data horizon visibility that you require. So we're very excited about unlimited data and that we can provide that to you at no extra cost.
I'm glad you took advantage of that opportunity to say, but wait, there's more. Be too good to miss that. So, after you've got all that data stored, the next step is really, how do we get access to it? How do we query it, and how do we make use of it? And so, we talk about the end value often with data is visualizations, but those visualizations on the front end run through a back end. And really it's APIs that sort of stitch this process together. So we have back-end code that can query databases, but then that back-end code is exposed as an API so that we can build a good front end. Those APIs can also be made accessible to third parties so that someone can actually build their own integrations based on either pulling data out of the system or even pushing data into the system for different reasons. And there's really a few different things that we kind of care about and want to evaluate here, which is, whether we have a flexible way to query the data, whether, whether it can render quickly or whether there's performance on those queries, and then just kind of evaluating APIs to look at whether or not we have functionality from an API to solve those problems. So we're going to just show you a quick example of API. So this is a tool called Postman. Many of you have probably seen it, used it, or heard of it. It's basically a tool to explore and interact with APIs and test them out. So what you'll see here is a collection over on the left, which is different types of GET queries. So this is like an HTTP GET function. So we'll call a specific URL, which is like an API endpoint. So these are identity APIs that are basically going to give us back some information from the system when we call this API. So when I send this out, you'll see this response comes back. And so as part of this identity API, basically what we asked for was a set of groups for group accounts or user groups. So it'll give us an ID, and it'll tell us the name of that. It'll give us the SSIDs that are connected to it. And the cool thing with APIs is when this is code, you can just take that ID that we got back, and now we can feed it into a new API. So what you'll see here is that we're using an HTTP post now to actually send data into the system. So it's a very similar URL, but as a post, and then a body that we're supplying with it we're actually telling the system what we want to post, which what we're doing here is creating a new private pre-shared key. We're going to assign this to a user and a specific user policy. And I'm the user in this case, so when it's actually pushed, it's going to then send me a text message telling me about this credential that's been created through our API call. So I'm just pulling in here my text message that shows, here's your specific password, here's the network it's connected to, and here's the expiration date for that. You see also in Postman here in the background that there's a JSON formatted response that comes back. And so this is what's used from the code perspective to make all this work.
So Marcus just showed you what is known as the Identity API for our private pre-shared key security solution, PPSK, which is popular with our customers. What it is individuals or unique devices can all have a unique pre-shared key, which means unique encryption as well as unique authentication credentials. It has three really cool use cases. One popular use case is you can have secure and encrypted guest access, and the PPSK, the unique one, is actually your credential to get onto an encrypted guest network. It's also a wonderful solution for BYOD security onboarding, and also IoT, which there's not a lot of 802.1x support for IoT devices. You can provide unique authentication credentials with private pre-shared key. Once again, this can be done through our Identity API, and a lot of our customers and partners are already taking advantage of this, including this PPSK kiosk application that you see right here.
Yeah, it's good stuff. PPSK solves so many different problems. So, now that we've kind of finished with all those stages, we're finally at the last stage, which is kind of thinking about action or output from the data. What's the value that we actually get from the data? And there's kind of a few common threads here. One of them is the front end, or the UI, is a primary way today that we get this value. And that comes from charts and graphs, tables, time series data, comparative analytics, root cause analysis, recommendation engines, even from logs and events. Like, we don't think of those as sort of like UI centric components, but ultimately we interact with that output from data as a UI function. And then the other way is really whatever we build with our APIs, and we kind of say, the world is your oyster, take our APIs and build whatever you want. And there's so many different layers here, so many things that you can get, or so many ways that you can extract the value from the data, but they kind of fall into these two categories. So ultimately what it comes down to as sort of an evaluation is, does the UI solve problems? Is it easy to use? Is it easy to understand? Is there enough intelligence in the system to help you get to problems, to resolving problems and fixing them faster? And then is there visibility into all of that good, rich data that's yours as a customer to own and to use to actually solve problems? So in order to sort of illustrate this, we're going to jump into just one final demo, which shows a topology feature within Cloud IQ.
So as Marcos was saying, in the final output stage of the data pipeline, it can be a lot of different things, but probably the one that most people are familiar with is a user interface. And what we're actually looking again is at Extreme Cloud IQ Pilot, and we're looking at the topology view that provides a lot of value in terms of what you can do with data and visualizing that data about what's going on with your network. The topology view is a top to bottom view from the access layer all the way to the core of everything going on with your network. And as an administrator, you can immediately start manipulating this data and interacting with this data. So to show you right here is, as an administrator, can click on a switch and start looking at the wired clients that are connected to the switch and getting real-time and historical information. Can also even look at some alarms for that switch, as well as maybe even do some advanced troubleshooting through an SSH proxy. Now we'll take it a step further. An administrator could click on the link between a access point and a switch and take a look at information about that uplink, including is this a trunk port? Is it an access port? If it's a trunk port, what VLANs are supported? Look at the amount of traffic that's being set up this uplink, the amount of power draw that's being from this device like the AP, the speed, as well as more information about the overall power budget of the switch. Finally, when you go closer to the access layer, you can click on an AP, see the clients that are connected to the AP, what VLANs are being trunked to this AP, also do some troubleshooting, even reboot the AP, see its neighbors. And a very useful tool that's been very popular with a lot of administrators is the VLAN probe tool, where you can have the management interface of an access point quickly probe from the access layer all the way to the core or to where the DHCP server resides, and to see if the VLANs are indeed functional in your entire network as well as their corresponding subnets. So we want to thank everybody for their time in attending this session. With that, I want to plug this book called Cloud Managed Networking for Dummies. It's not really for dummies because the guy that wrote it's kind of a genius. His name is Marcus Burton, my co-host. It's a 80-page booklet about cloud technologies in general and all the different aspects of cloud, as well as machine learning, AI, and of course the data pipeline. So please take a time, use the URL, and download this free ebook. Any final words, Mr. Burton?
Well, you just shot yourself in the foot, man. You said I'm a genius, so no one's going to believe anything else you said. No, nothing else. I mean, captured it well. We want to just keep reiterating that we do believe that cloud and data are, the sources of value in networking today. And so we're going to keep sort of pushing this topic. We'd love your feedback. Thanks for joining us. We appreciate it.